Hi everyone, today we are going to go over the study guide for 7-1, 7-2, and 7-4. Our quiz will be tomorrow. Remote learners, please remember if you are taking your quiz at home tomorrow, you are expected to take it during your scheduled geometry period. As always, email me if you have any questions. All right, so number 1, what is the length of the third side of a right triangle with a leg of 14.5 and a hypotenuse of 21? My first step is I'm going to draw out this right triangle. So remember, our hypotenuse is always across from the 90-degree angle, which means 21 is going to go in this spot here. So I need to figure out what is my other leg. All right, so Pythagorean theorem, a squared plus b squared is equal to c squared. So I have 14.5 squared plus x squared is going to equal 21 squared. If I plug this into my calculator, I get 210.25 plus x squared is equal to, and if I put 21 squared in my calculator, I get 441. All right, so I need to subtract 210.25 from each side, which gives me that x squared is equal to 230.75. I don't care about x squared, I just want to figure out what is x, meaning I need to square root each side, and that gives me that x is equal to the square root of 230.75. And if I wanted to approximate this to 2 decimal places, it would be, or let's do 1 decimal place, it'd be 15.2. What is the length of the third side of the right triangle with legs of length 14 and 50? So once again, I'm going to draw out this triangle. This time I'm trying to find the hypotenuse, which is x. So a squared plus b squared is equal to c squared. So 14 squared plus 50 squared, let's fix that, is equal to x squared. All right, so I can plug this right into my calculator, and I get 2,696 is equal to x squared. So the square root of 2,696 is equal to x. And if I wanted to approximate that to 1 decimal place, it would be approximately 51.9. Number 3, are the following numbers Pythagorean triples? You will not be quizzed over this. I think it was section 7.2 at the very end of the Ed puzzle. I talked about Pythagorean triples. So which one is a Pythagorean triple? It would be B here. Why? Well, if I divide all of these by 6, this would give me a 3, 5, and 4, and we know that a 3, 5, 4 triangle is a Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared. So remember, this is just a little cheat or a shortcut to figure out if the sides are a right triangle. Number 4, determine if the segment lengths will form a triangle. If so, would the triangle be acute, right, or obtuse? All right, so let's start with A here. The first thing we need to decide is, will this create a triangle? So to determine if the lengths will create a triangle, we want to look at the 2 shorter legs, add them up, and see if they're greater than the longest leg. So in this case, 8 plus 10, is that greater than 12? It is. So this will create a triangle. So now my second step is to decide, okay, what type of triangle is it? So 8 squared plus 10 squared. How does that compare to 12 squared? All right, well, if I plug this into my calculator, I get 164. And if I plug 12 squared in my calculator, I get 144. We know 164 is greater. So that means that I have an acute triangle. Let's look at B here. So the first thing I need to decide is which side length is the longest. And my longest side is the square root of 73. So step 1, will this create a triangle? Is 8 plus 3 greater than the square root of 73? And it is. So step 2 is to determine which type of triangle we have here. So 8 squared plus 3 squared. How does that compare to the square root of 73 squared? All right, well, if I plug this into my calculator, I end up getting 73. If I plug this into my calculator, remember if you have a square root and a square, those just cancel out. And so that equals 73. So these are equal, meaning that this is a right triangle. And for part C here, I'll write this over here. I kind of ran out of room. I have 12, 5, and 20. So 20 is the longest side. So for number 1, is 12 plus 5 greater than 20? Well, 12 plus 5 is 17. Is 17 greater than 20? It's not. So this will not create a triangle. And so I'm done because if it's not a triangle, it can't be acute, right, or obtuse. Number 6, given the two side lengths of 20 and 48, give the possible lengths of the third side in order to form a right triangle. Decide if your third length will be a leg or a hypotenuse. All right, so in this case, there's going to be two scenarios. The first scenario is that the side we're looking for is going to be a hypotenuse, and the other scenario is when x is going to be a leg. So let's draw out both of these situations. So let's solve for x in our first scenario where x is the hypotenuse. So I'm going to have 20 squared. Sorry, that squared is really bad. Plus 48 squared is equal to x squared. So if I plug this right into my calculator, I get 2,704 is equal to x squared. If I square root each side, I end up getting that 52 is equal to x. Let's look at our second scenario. If x is a leg, I would then have 20 squared plus x squared is equal to 48 squared. Subtract 20 squared from each side. X squared is equal to 1,904. So x then is equal to the square root of 1,904. And if I wanted to approximate that to one decimal place, x would equal 43.6. The next few problems are going to talk about our special right triangles, a 45, 45, 90, and a 30, 60, 90. It would be very beneficial to have your cheat sheet right in front of you, or if you wrote these down in your notes. So for number 7, the leg of a 45, 45, 90 triangle is the length of 5. What will the length of the other leg and hypotenuse be? My first step is I'm going to draw out this situation. So I need to figure out what is the length of x, the other leg, and what is the length of y, the hypotenuse. Well, if you look at your cheat sheet, we know that a 45, 45, 90 triangle is an isosceles triangle, meaning that the legs are congruent. So if one leg is 5, x also has to equal 5. Next, we want to figure out what y is, which is the hypotenuse. And we know from our cheat sheet that the hypotenuse is equal to the leg times radical 2. Well, the leg is 5, so the hypotenuse has to equal 5 radical 2. So y is 5 radical 2. The hypotenuse of a 45, 45, 90 triangle is the length of 14. What will be the length of the two legs? So here's a picture of my right triangle. So we know that 14 is the hypotenuse. So I need to figure out what the legs are. So once again, the hypotenuse is equal to the leg times radical 2. Well, hypotenuse is 14. So that's equal to the leg times radical 2. So this is going to be one of our funky situations where I need to get rid of that radical 2. And to do so, I need to divide by radical 2 on both sides, which means that 14 over radical 2 is equal to our leg. However, we are not allowed to have a radical in the denominator. So if I have 14 divided by radical 2, to get rid of this radical 2 in the denominator, I need to multiply both the numerator and the denominator by radical 2. So when I multiply the numerator, I end up getting 14 radical 2 divided by radical 2 times radical 2 is just a positive 2. Then I can look at 14 divided by 2. We know that simplifies to 7. And then radical 2 just stays as radical 2. And I'm done. So my leg then is equal to 7 radical 2. And this leg is also equal to 7 radical 2. Next, we're going to move on to a 30, 60, 90 triangle. So the hypotenuse of a 30, 60, 90 triangle is the length of 32. What will be the length of the two legs? So here is my problem, and I know that this is, we'll say that this is 30, this is 60. All right, so we know the hypotenuse. So looking at your cheat sheet, I want to use the hypotenuse equation for a 30, 60, 90. And so in this case, the hypotenuse is equal to 2 times the short leg. Well, looking at my 30-degree angle, the side opposite of the 30-degree angle would be my short side, which is y. So if the hypotenuse is 32, and that is equal to 2 times the short leg, to figure out my short leg, I would divide by 2 by 32. And when I do so, I end up getting that 16 is equal to my short leg, which in this case is y. Next, I need to figure out what is the length of my long leg, which is x in my diagram. So the long leg is equal to the short leg times radical 3. Well, the short leg we found out was 16. So 16 times radical 3, and I'm done. So x is equal to 16 radical 3. The shortest side of a 30, 60, 90 triangle is the length of 6. What will be the length of the other two sides? So here's my sketch of my triangle. So I know that opposite of the 30-degree angle is my short side, so that's where the 6 goes. So let's first find the hypotenuse. And we know the hypotenuse is equal to 2 times the short side. All right, so 2 times, well, the short side is 6. So my hypotenuse then is equal to 12. So y is equal to 12. Next, we need to figure out what is the length of the long side, or x. So the long side is equal to the short side times radical 3. Once again, the short side is 6, so I'm just going to replace the short side with 6, times that by radical 3, and I'm done. So x is equal to 6 radical 3. The opposite side of a 60-degree angle of a 30, 60, 90 triangle is the length of 12. What will be the length of the other two sides? All right, so if the side is opposite of the 60-degree angle, that means it's the long side of the triangle, or the long leg of the triangle. And we know that the long leg is equal to the short leg times radical 3. So if the long leg is 12, we need to search for the short leg. Now this is going to be one of our weird problems where I have to divide by radical 3 on each side. Divide by radical 3. So we know that the short side is equal to 12 over radical 3. However, we cannot have a radical in the denominator. So to get rid of that, I'm going to multiply by radical 3 over radical 3, which will give me 12 radical 3 over 3. Now I want to look at those two numbers. Do they divide into a pretty number? And they do. 12 divided by 3 is 4, and I'm going to keep that radical 3. So my short side, or x in this case, is equal to 4 radical 3. Now I need to figure out what is y, or my hypotenuse. And up here I'll write that the hypotenuse is equal to 2 times the short side. So 2 times, well, my short side is 4, the square root of 3. When I multiply this, I just want to focus on these two numbers. And so 8 radical 3 is the length of my hypotenuse, or y. So 8 radical 3 is my answer. Finally, we just want to practice simplifying radicals. So for my first example here, I have radical 5 in the denominator. So what am I going to multiply this fraction by? Well, I need to multiply it by what's in the denominator, which is the square root of 5 over the square root of 5. So when I simplify this, I end up getting 80 radical 5 divided by 5. Let's look at this fraction. Does that simplify? And it does. 80 divided by 5 is 16, and I'm going to keep that radical 5. Our next problem, 36 divided by the square root of 10. So what am I going to multiply this by? Well, I'm going to multiply it by radical 10 over radical 10. So when I simplify this, I get 36 radical 10 divided by 10. Will this simplify? It does. Both of those are even numbers. So if you plug 36 divided by 10 in your calculator, you end up getting a simplified version of 18 over 5. Don't forget about that radical 10. And that's as simplified as we can get.